Hello everyone, let us now discuss how can we solve this problem today's LeetCode period today. But it is marked as hard and also the acceptance rate for now is 35%, and I request you to like this video if you like the explanation and also do subscribe to my channel, and let's dive into the question firstly. Now we are given with a string num. Okay, we are given with a string num, and I am here to make this question and the explanation clear for you. A string of digits is called balanced if the sum of the digits at even indices is equal to the sum of digits at odd indices. Okay, what does this mean? It is like 0, 1, 2, 3, 4. So what are the even indices? Even indices are 0 to 4. So the sum of these indices should be equal to the sum of L digits at these indices should be equal to the sum of digits at these indices. The sum at odd indices. The sum at odd indices should be equal to sum at even indices. Okay. Return the number of distinct permutations of num that are balanced. So if the sum of odd digits at that indices and sum of even indices, the digits at even indices, if they both are equal, then it is known as balanced permutation. Okay, now we need to return the number of distinct balanced permutation. Okay, since the number may be very large, return in modulo 1 in 9 plus 7. Let us go, and a permutation is arrangement of all characters of a string. So let us get into this example instead of going to those examples which you have already given in the description. Even, even, even. So 1 plus 3 plus 6 will be equal to 10. Okay. Now I have 5, 1, 4. Now I have 5, 1, 4. These are odd indices. 1, 3, 5. At odd indices, I have 5 plus 1, 5 plus 1 plus 4. So total will be 10. Now we need how many arrangements we can make to this number, and it's not always sure that this will be something like 6 and 4. It can also be something like this, and you need to know what are the permutations, right? So now let us see why this brute force doesn't applicable here. So the constants are very big, and here there are EIT. So the number of permutations are nothing but n factorial, which is EIT factorial. Now let us see what does EIT factorial give us. EIT factorial will give us 7.1 something, 7.1 plus 1 EIT. What does this mean? Like 7 something like this. It is nothing but 1. What does this 1e5 mean? That means after 1 take 5 times zeros. Now after 7 take zeros for how many times? 1, 1, 8 times. Okay, for now it's clear, right? Now as I said, the brute force will fail for sure. So the brute force will fail for sure. Now what are the observations? Just observe what I am saying. 1, 3 and 6 give me 10. The even indices give me 10, and the odd indices also give me 10. But if you see, the even sum and also the odd sum should be equal to the total sum. Okay. Now, as they both are equal, I am considering them both of them as S. S plus S should be equal to total sum. Now, S should be S should be TS by 2. Nothing but total sum by 2. Okay. Right. Sum is total sum by 2. But wait a second. If total sum is odd, just like I have 1, 1, 1 as num, do I get sum plus sum is equal to total sum? How do you divide this 1, 1, 1, which is having the total sum of 3? Now, how can we divide this? we cannot divide, right? We cannot take 1.5 as the sum. We are not given with the float values. Instead, we are given with integer values. So it's not possible. First observation is the half solved problem, right? The first observation have made clear that if if total sum is odd, then return 0. What does this mean? If the total sum is odd, then we cannot take any permutations. That's what this total sum is odd, then return 0 mean. Now, let us see what is the frequency of every number. Let me write it. I'll write 1 is present for how many times? 1 is present for 2 times. Here 1 time and here for 1 time. And I have the next number 3. How many times? 3 is present for 1 time. Okay, wait a second. Okay, wait a second. Now I have 4. The next number is also present for only 1 time. And I have 5 which is present for 1 time. And I also have 6 which is only present for 1 time. I am keeping this aside. But if you see here, I am just taking instead. I am just taking this, right? 153164. Now I have at this point 1, 3 and 6 is giving a sum of 10, right? 1, 3, 6 is giving a sum of 10. 1, 6, 3 will also give a sum of 10. 3, 6, 1 will also give a sum of 10. Here is the main thing of combinations. Combinations. Right, here comes the main thing of combinations. So we have three positions and also we have these three things and we need NCR, right? We need NCR, right? So here I have 1 and also 3 and also 6. We have three positions and also we have three numbers. So we need how many times or how many permutations that we can get, right? I can make something like 3 here and also 1 here and also 6 here. I have 6 and 1 and 3. I'll tell you why how this works. Now the next question is, where do we go for NCR? For NCR we are not something like n factorial n minus r factorial n minus r factorial into r factorial. But wait, what if I stored n in I, that means in rows, and r in columns, right? It might be a simple and also easy way to get NCR in big O of 1 time complexity, right? So if not, I need to take n big O of n plus r. I think it's the total time complexity for calculating NCR without this table, right? Now where do we go for NCR? 0C0 will give us 1, and also here also it is 1, here also it is 1, 2C0 is also 1, 3C0 is 1, and it is basic maths. I think it's no need to explain you again. 1C1 is 1, 2C2 is 1, 3C2 is 1, 4C2 is also 1. But wait, what is 2C1? 2C1 is nothing but 2 factorial by 2 minus 1 is 1 into 1 is just everything will be computed to 0. It is nothing but, okay, for now it's 2. Now I have 3C1, 3C1, 3 factorial, 3 factorial by 3 minus 1, which is 2 factorial into 1 factorial, and it will be after that, after the calculation, it is 3. Now here comes the another thing, 3C2, right? 3C2 is again 3 factorial by 2 factorial and 1 factorial. So it also results in 3, right? What does this mean? I am just adding. If you see, if you did something like a small dp, 2 plus 1, here also 2 plus 1, here also 1 plus 1, and if you doubt, check it. 3 plus 1 will be here, 3 plus 3 will be here, 3 plus 1 will be here. Now I'll write them again. 3 plus 1 is 4, 3 plus 3 is 6, 3 plus 1 is 4 again. I think for now it's clear to compute all this all these things. Now recursion plus backtracking and resulting in memoization. Now, before that, I need to tell you that prefix or something like prefix array, right? I'll store this prefix array. Now, how does this prefix array store? Now, I have 1, but before that, I have 0. What does this 0 mean? At 0, I have how many possibilities? I have 1. And 1 has how many possibilities? I can even place 1. Why? Because I have 1 for 2 times. Okay, for now 2 times 1 is calculated. Now after 1 I have 3. Okay, perfect. Now for 3 I have 4, and for 4 I have 5, and for 5 I have 6. But wait, here for 0, what are the total digits that I can or I have possibility to place, right? Where they are 6 possibilities. Okay, for 0 there are how many possibilities? 1 2 3 4 5 6. 6 possibilities. Now for index 1 I'll just shift it there. For index 1, for index 1, sorry, for 1, number 1 I have, including 1, I have 6. But you might get this question, but here when you are starting from 0, you didn't include that 0. Why? Why? Because 0 is not present in the given string. That's why I am considering, and I also will be telling you how to compute the numbers or prefix numbers, and I'll be changing that variable number in name in the code. Now okay, for 1 I have 1 2 3 4 5 6. Okay, I have 6. Now again I have 1 again. So here also I have only 1, but here I am just computing till 1. Now what if I have a 2? What if I have a 2? For 2 I would start with 3, and I have 4 numbers, right? Okay. For 3, including 3, as 3 is included, 3, 1 2 3 4. Okay, 4 times. Now I have 4. Okay, that means I am starting with 4, and I also have this 4, just 3. Now I have 5. So what is for 5? For 5 I have just 2, including 5. Okay, 2. For 6, I just have 1. Okay, I have, for 6 I have 1. Now what are the next elements? What are the next elements? Now I'll tell you what are the next elements clearly. 7, 8, 9 are 0, 0 and 0. Now instead I'll tell you how the prefix sum will be working here. For 9 I'll place another number 10, right? 10 will be having 0 and everything will be 0, but I will be checking the frequency every time. I'll tell you what is the formula for that, but before, let me take the frequency map. Okay, I have frequency map, or I will be storing that in an array in the code. Okay, now my formula is prefix array or something like it. Prefix array of I is equal to frequency of I plus prefix array of I plus 1. That's what is going on. Why? I'll tell you how this works. Now for 5, I already have for 5 only one time, and for 6 I have one time. I just added for 6 how many, that means how many times after 6 I can go is only 1, including only 6. So I have added 1 to the frequency of 5. So as I am saying, for 5 I am starting with 5, that means I am including this 5. So when I including this 5, there might be 5 for many times, as 1 is there for 2 times. And there might be another question. So that's why frequency of I plus pre-array of I plus 1 will be calculated. Now 9 is having 0 as the frequency. If there is no number in an unordered map, or if you use for example 7, there will be 0 as I am using here array, count array. 8 is for 0 times and 9 is also for 0 times. Now 9 is for 0 plus 0 will be 0. 8 is 0 plus 0 is 0. 7 is 0 plus 0 is 0. 6 is 1 plus 0 will be 1. 5 is 1 plus this one. 1 here, 1 plus 1 will be 2. 1 plus 1 will be 2. Now I have 4 here, and pre-array of I plus 1 here. 2 plus 1 is 3. Okay. Now I have 3. 3 is present here, and I have this one. Pre-array of I plus 1 is 3 plus 1 is 4. Now, okay. Now I have 2. No, here 2 is present for only 0 times, right? Is 0 times. Now, here 2 is present for 0 times. Pre-array of I plus 1 is 4. 0 plus 4 is 4. Now I have 1. 1 is present for 2 times here. 1 is present for 2 times here. Wait a second. Right. 1 is present for 2 times, and I have 4. 4 plus 2 is 6. Now 0 is present for absolutely in our string 0 times. So 0 plus 0 is 0 plus 6 is 6. They both are equal. That's how the prefix array or prefix sum will be working. Now I got prefix array and all these things. Why? The next question is, why are you storing this prefix array? Why are you storing this combinations? Why are you computing this NCR? Why are you taking this total sum? Why are you taking this sum? I am just mixing up all for why. Now just imagine you are having a recurrence call with odd sum and also odd places or odd count. Now how does this count look like? And I'll tell you what is this odd count. And I think I have another thing, this prefix array and also this count, this NCR matrix will be sent. But most importantly, target sum. Now I'll tell you how. So just just take this 15364. Okay, just take this 15364. Now I have, what are the odd indices are for 3 times, so I need 3 odd indices to be placed. I name it odd count. So odd count, I also tell you how is this working. Just wait. Now what should be the target sum? So what should be the target sum? Target sum is total sum by 2. Target sum is nothing but total sum by 2. What is total sum? Total sum is 20 by 2 will be 10. So the target sum is 10. What is the odd sum? Odd sum. The odd sum will be telling us, here comes the most crucial part. Here, as I said, 1 is present. 1 is present for 2 times, 2 is present for 0 times, 3 is present for 1 time. At this, I'll check what is the frequency of a digit. Okay, what is the frequency of digit? Now, the digit is 1. Now, what is the frequency of 1? Frequency of 1 is 2. Now, I have to place it if it is lesser than the odd count, right? Odd count is nothing but 3. That means I only have 3 places to place the odd sums. But you, in the mind, you are recalling, what about even places? I'll tell you, I'll get there. Odd count, 2 is less than or equal to odd count. So I can take this 2, or even I can take 1, or I can take 2. So I will take something like k is equal to 1, and it should be, the k value should be less than or equal to minimum of odd count, wait a second, odd count and frequency of d. frequency of D is nothing but 1. D is nothing but 1. So let me write it over here. D is nothing but 1. So frequency of D. Why I am taking the minimum? Why? Because if there might be a problem that D is present for and is there, right? D is present for 2 times and there are 3 odd places that I can place. So I cannot exceed my K greater than the minimum of these two. So I doesn't have D. The frequency is just 2 and even I have 3, I can only place the minimum is nothing but the frequency. So that's why K should be less than or equal to minimum of odd count, comma frequency of I. So here the recursion comes into picture. I'll take K is equal to 1 and I take K is equal to 2 and less than or equal to minimum of frequency of digit, comma remaining element, odd count. The odd count firstly will be 3. So the odd count firstly will be 3. Then after placing a 1 in the string, after placing a 1 in odd number, that will be okay. Then the remaining count of odd count will be decremented. Okay. Now the question which is in your mind, what about even? What about even? If I take 1, if I am taking digit 1 and placing it in my odd, what will be placed here? What will be placed here? It is the doubt which is in your mind. I'll tell you. All the other, I am just taking K is equal to 1. That means I am just taking digit 1 for one time. Now, all the other times, all the other digits, I'll tell you, D's, all the other D's will be placed in even indices. Will be placed in even indices. Why? Why? Because we are strictly bound. We are strictly, we strictly take digit for for only k times the two in odd places, odd indices. Let me write it as odd indices. So only odd indices I will place only for k times. If I took something like 1 has the frequency of 5, then k, if I take k is equal to 3, that means I am taking 3, then I will place a 1 here, I will place a 1 here, and the remaining frequency of D, the digit D minus k values will be placed in even indices. Okay. Now it might be clear for you. So it will be something like at even indices, we are left over with 5. In 5, I have placed only 3. Then I am remaining with other 2 ones. I'm just taking a random example. Don't be worried about what will be the answer. So there might be another digit for that. So how is this recursion changed to DP? So you might get an answer here and the same overlapping sub problem here. So why we need to calculate the same thing again? So the base case is when the digit is equal to 10, I'll be starting from 0 and going till 10, right? I'm just going increasing the digit. So it when it touches 0, then if current odd sum is nothing but the odd sum which we got. Now, if I just take a look at a recursion table, then you can understand the base case. Now, I have 1, 5, 3, 1, 6, 4. I'm just starting here and I am going here. Like I just took 1. I can take 3. I can take 4. I can take 5. I can take 6 in odd places. In odd places, right? In odd places for 3 times. Now I have 5, 1, 4 at odd places. After 1, I can go even to 1 and 3 and 4 and then 5 and then 6 again. For 3 also I have 1. Why not 3? Why not? Because 3 is present for only one time. Right. 1 and then again a 1 again, 4 and a 5 and 6. But do you need to write this 1 again? Absolutely no need. So I just need to write 1 for just one time. I am choosing to go to 4. Then after 4 I can go from 1 4. I have left with 1 3 5 6. So here comes the actual solution. 1, this 4 and then this 5. 1 plus 4 is 5. 5 plus 5 is equal to 10. Okay, for now I think it's understood for you. Current odd sum is equal to the target sum. That's what I wrote in the condition. Current odd sum is equal to target sum, and odd left. What does this odd left mean? So I have here the odd indices left are, initially here there are 3 and then 2 and then 1 and then 0 odd indices left. So odd left is nothing but the odd indices that we have to place the digits there. Then it is a valid permutation and I'll return 1 there. So I'll return a 1 and this one will be returned to here and this one will be returned to here. I might also get again from 1, I think I will get from 1 I'll get a 5 and from 5 I'll get something like this. But every time I get a valid permutation, then if this any of these two is not working or is false, then return 0. Now invalid paths. So if current sum is greater than the target sum, then we need to stop. We only need 10 as the sum. Now if odd left are less than 0, that means I have pushed even lesser than 0, that means I went to -1, then we need to stop. That means there are many odd places we are trying to store other than required. Now recursion logic will be, for current digit d from 0 to 9 we place k copies. As I said, k copies is nothing but 1 and then so on, will be frequency of d. Remaining is frequency of d minus k copies, right, where we place the even positions. That's what I said. Now recurs to the next logic. Current odd sum is plus is equal to k into d. Update odd left is equal to minus is equal to k. That means if we place two places, that means if one is present for 2 times and I have placed in odd indices for 2 times, then what are the remaining odd indices left? Total minus k. I have for 2 times. So total minus k, odd left minus k. Now why we are using this dynamic programming is nothing but in a lesser constant like 10 or something like even 5 to 10, I am just analyzing or just making an assumption, then we can use this recursion logic, just write this recursion without any memorization. But here we need a 3D table where it stores the digit, right? It stores the digit and the current odd sum and also number of odd indices that are left, the odd indices that are left, the sum till now, and by taking the digit. Number of ways to assign digits from digit 0 to 9 given the current sum and remaining odd positions. And I have the code given in the link in the description. And if you like this video, do share it to friends and do subscribe to my channel. But before that, if you have any doubts and any queries, then feel free to comment in the comment section. Thanks.